everyone, I'm excited to get started with our very first problem-solving strategy that we're going to work through today, guess and check. So we're going to talk about how we can apply Polya's principles and use this strategy when we solve problems. Hopefully you guys have been following along in either the physical textbook or the e-text version on Pearson MyLab. If so, we are in section 1.2. We're continuing on with that section. Okay, here we are in our first problem-solving strategy, guess and check. Guess and check is an extremely awesome strategy. It's like the old reliable of strategies. If you aren't sure what to do, you can always use guess and check. I find that people tend to sort of shy away from it because it's not some fancy strategy. No. It is one of the most powerful strategies you have because you can always use it to get you started. So what do you do when you guess and check? Well, you make a guess and you check to see if it satisfies the demands of the problem. If it doesn't, alter the guess appropriately and check again. And then when the guess finally checks, a solution has been found. So this strategy in and of itself really gets at the heart of Polya's problem-solving principles, right? Our first guess might not check out, and our second and our third and our fourth and our fifth might not check out. But each time we make a guess, we're going to notice something. Like maybe when we made a guess, the answer was too small. So we know we need to alter the guess and make it a little bit bigger so that our answer gets bigger. So guess and check helps us to notice patterns, relationships, and it certainly gets us started. So it's a really strong strategy. Okay, so now let's apply the strategy of guess and check to a problem. Let me pull my problem up. In the first diagram, the numbers in the big circles, these big blue circles, are found by adding the numbers in the two smaller adjacent circles, these pink ones. Complete the second diagram so that the same pattern holds. So I notice that in my second diagram, these small pink circles are missing numbers. So first of all, I need to go back to Polya and his problem-solving principles. I'm going to use my mnemonic. Unicorns paint energetic rainbows. That U stands for understand. And we learned in the last lecture that this is an extremely important principle. If we don't understand a problem, we can't possibly hope to solve it. So I need to take that moment to reflect. I can use some of those prompting questions to make sure I understand this problem. So a really important question for this one would be, do I understand all the words in the problem? You're going to have a lot of students who get stuck on this word adjacent. Adjacent just means if I look at the numbers in the big circles, the two adjacent circles are the ones that are right next to that big blue one. So the 2 and the 6 are right next to my 8. So I need the numbers in the big circles to be found by adding the numbers in the two smaller adjacent circles. So here are my adjacent circles. 2 plus 6 equals 8. What circles are adjacent to my big 14? 2 and 12. 2 plus 12 equals 14. And what circles are adjacent to my 18? 12 plus 6. Okay, that gives me my 18. So now I need the same property to hold down here. And so now that I understand all the words in the problem, I understand what I'm being asked. I've taken the time to put it in my own words. Now I can move into Polya's second principle. So again, unicorns paint, that P stands for plan. That just means I need to think about all of the problem-solving strategies I know and pick one to get myself started. So I already know, because I told you we're going to use guess and check, but maybe I don't know how to solve this problem. I don't even know how to get started. So guess and check would be a good strategy to start with. So I've got my plan. Now I need to move on to Polya's next principle, unicorns paint energetic, that E stands for execute, which just means I need to get started with the problem. So I want you guys to grab a pencil, a piece of paper, and I want you to start guessing and checking. Really start guessing and checking, and don't come back to this video until you have the answer. So click pause and see what you find. Welcome back. So hopefully you did actually pause the video and work through this problem. You will get so much more out of this class if you do these problems with me and interact with the lectures and try what I ask you to try. And it will be so much more fun and interesting too. So when you got your solution, you should have wound up with 6, 10, and 5. We know that 6 plus 10 gives us our 16, 6 plus 5 gives us our 11, and 10 plus 5 gives us our 15. Okay, and maybe you got really lucky and you got it on the first guess, but maybe it took you 2, 3, 4, 5, 6, 7, however many tries. Who cares? You tried it, you got there, maybe you noticed some relationships, and hopefully you were using each guess to inform the next. All right, so we've worked through Polya's principles, the first 3, understand, make a plan, right? We chose guess and check as our plan, our strategy, and then we executed our plan by actually guessing and checking until we found the solution. So now we can move into the fourth principle. So if I go back to my mnemonic, unicorns paint energetic rainbows, that R stands for reflect. And so in my previous lecture, you guys know I said reflection is really the heart of this. Reflection is the heart of math. Like, it's really good to be able to calculate numbers and things like that, but true math is looking for patterns. It's looking for relationships. Patterns are what math does to talk to you, to communicate to you, to say, hey, something really cool is happening here. And it's only by reflecting that we actually can find those sorts of patterns and relationships and learn how to apply them efficiently. So I want to reflect on this problem because while guess and check is a great strategy for getting us started, it is never the most efficient strategy ever. So it's really good for getting us started, but there's always a better way. And so in this reflection, I know that I probably could find the solution in a much better way rather than guessing and checking, because if I had this problem on a much larger scale with many more circles, I wouldn't want to be sitting there for hours and hours guessing and checking. I would just want to get there. And so I know that the key to that, this problem is all about relationships, right? So first thing I'm going to say to myself is there a better plan or a better strategy than guess and check? And how am I going to find it? Well, I'm going to look at that relationship between the numbers in the large circles and the numbers in the small circles, because that's what this whole problem has been about. There's some sort of special relationship here. So if I can crack that, then maybe I can find a better strategy. So I'm just going to start. I always just start with what I know. Okay, I know that the numbers in my large circles come from the sum of the numbers in the two small adjacent circles. So my 8 here came from 2 plus 6, right? I know that. The 8 came from 2 plus 6. I know my 18 came from 12 plus 6. And I know that my 14 came from 2 plus 12. And similarly, I know that my 16 came from 6 plus 10. And my 15 came from 5 plus 10. And my 11 came from 6 plus 5. I know that. And so now I'm just going to take a look at this and see if there's anything I noticed. It's all about patterns, all about relationships. So look at these numbers and take a second and see if there's anything you notice. I don't know about for you, but for me, what I noticed when I first took a look at this problem was that every single number in the small circles gets used exactly 2 times. So I've used this 2 right here. I've used it twice. I've used my 6 exactly twice, right? 1, 2. And I've also used my 12 exactly twice. 1, 2. Similarly, let's see if that happened down here for the second one. Okay, let's start with my 6. I've used that exactly 1, 2 times. My 10, I've used exactly 1, 2 times. And my 5, I've used exactly 1, 2 times. And so like I said, guys, I've noticed a pattern. A pattern is math screaming at me, there's something here. The math is talking to me, right? It's saying, look into this. There's something cool here. All right. So the other thing I know about this problem right here is that it's all about adding, right? So I had to add the numbers in the small circles to get the sum, to get the number in the large circles. So what I'm going to do is I'm just going to add. I'm going to take the numbers in my large circles, the 8, the 18, and the 14, and I'm going to add it together. So let's see what I get. 8 plus 18 plus 14, that gives me 40. And along those same lines, let me add the numbers in the smaller circles. So 2 plus 6 plus 12, that gives me 20. Now I'm getting really excited because there is a relationship between 40 and 20, right? 20 is exactly half of 40. And so that's kind of cool. Or another way to say that is 40 is double 20, however you want to look at it. So let's see if that holds now for the bottom diagram. So 16 plus 15 plus 11. I'm going to add the numbers in my large circle. That gives me 42. And so based on the relationship I've noticed up here, I know that the sum of the numbers in my smaller circles should be exactly half of 42. So half of 42 is 21. So I would expect that the sum of the numbers in my small circles should be 21. So let me add those up. 6 plus 10 plus 5, And that does, in fact, equal 21. And so you always want to just make sure these relationships, you notice, hold and check out, and it did hold here. And so that's really exciting because I now have this really cool, unique relationship that I can use moving forward to solve similar problems. And that's exactly what we're going to do on the next slide. Okay, so now I have another one of these diagrams, and I know I don't have to guess and check anymore to figure out what my A, B, and C should be. I have found this relationship of the sum of the large circles, right, and the sum of the small circles have this special relationship. Whatever the large circles sum to, the sum of the small circles should be exactly half. So let me start by summing up my large circles. I've got 12 plus 11 plus 9, which gives me 32. And so half of 32 is 16. So I know that when I add A plus B plus C over here, I've just given each of those circles a name, it should sum to 16. So what do I do from here, right? Well, I'm going to use a little bit of algebra. I know A plus B plus C should be 16. And I also know that A plus B should equal 12. And this is really the key that sort of unlocks the whole thing. Now that I know what A plus B is, I can just substitute it here. Right? A plus B equals 12. So instead of writing A plus B plus C equals 16, I'm just going to substitute this A plus B, this whole expression. Well, I know what A plus B is. It equals 12. So I know that 12 plus C equals 16. And once I have that, I've solved my problem. Now I can solve for C. C equals 4, right? And so now that I have C, I can go right back and I can say, okay, well, C plus B has to equal 9. But I know what C is. C equals 4. So 4 plus B has to equal 9, which means B has to equal 5. And then similarly, I can say, well, A plus C has to equal 11. But I know what C is. C equals 4. So A plus 4 has to equal 11, which means that A is 7. And if I go back and I fill that in, I know A is 7, and B is 5, and C is 4. That should work. So let's see, 7 plus 5 does equal 12, 7 plus 4 does equal 11, and 5 plus 4 does equal 9. And so you see how that relationship that we discovered wound up helping us to be way more efficient problem solvers. And that is the beauty of guess and check. It got us started, and then we used Pauli's fourth principle, reflecting and saying, okay, now let me see if I found some sort of special relationship here that will help make this more efficient. And I did. So always take the time to reflect, and remember that guess and check is a great strategy for getting you started on a problem. Don't ever be afraid to use it.